right, this is Engage in New York, Module 3, Lesson 3. This is Concept Development. So here we are going to start off with, we're actually not going to do this 4x4 piece of paper. Instead, we're just going to use the boxes that are on the page. But I want to start off by asking you, kind of giving you an example. So if I have one adult plus 3 more adults, that equals how many adults? Right. So it's 4 adults, right? So 1/5 plus 3/5 equals how many fifths? Right. 4/5, right? Okay. So now, what if I did one child plus 3 adults? Can we add children and adults? What do you think? Do you think, based on what you've heard me tell you so far about fractions, could you add children plus adults? Well, no. Children and adults are not the same unit, right? We would have to have like units before we added. So, but what do children and adults actually have in common? Well, they're people, right? So adding people, not children and adults. So if I said one person plus 3 people, well, that would equal 4 people, right? 4 people, which would be 4 units or 4 ones, correct? Yes. All right. So just to remind you that things have to be like units in order to add them in fractions. So can I add 1/2 and 1/4? So let's try it. So let's try to add 1/2 using the boxes we've been given, 1/2 plus 1/4. So let's now turn that and try to make like units. Well, how could we make like units? Well, if this is divided by 2, I wonder if we divide it by 4. 1. So if this is 2 on this side and we divide by 4 on this side, 1, 2, 3, 4, 5, 6, 7, 8. Now we have 1, 2, 3, 4 out of 8, right? Then here, so it's like essentially multiplying by 4, right? And we get 4/8. Now here, what if I have 4 here and I divide it into 2? Now I have 1, 2, 3, 4, 5, 6, 7, 8. Now I have 2 out of 8, right? So now we multiply this by 2, we get 2/8. So now let's come over here and draw that. So we divided it in half, right? And then we divided this into fourths, and we ended up with 4/8. Then we're going to add 2/8 to this. So we started out with fourths and cut it into 2, and now we have 2/8. Now they have like units. It's like they're sitting on the same number line. Now they're sitting on the eighths. number line. So you go 4/8 plus 2 more 8s, right? Before, this was sitting on the half number line, or the 2/2, right? The halves number line. So this would be 0/2, 1/2, 2/2. This one sat on the fourths, 0/4, 1/4, 2/4, 3/4, 4/4. Now we took these two fractions and we moved them to a like number line. We put them together. So now we have 0/8 to 8/8. Halfway would be 4/8, right? So if we started here and we went 4/8 and we added 2 more 8s, we would end up at 6/8, right? So I just want you to go ahead and see how those are alike. All right. So we solved it this one way. Now let's look at it again from a similar perspective. So we started with 1/2 again, like above, and we're trying to add it to 1/4, right? So this is 1/2 and 1/4. Now, if you notice, I started the first problem. I demonstrated, I'm illustrating, modeling the first fraction straight up and down. Now I'm modeling the second fraction going across, okay? So we are going to start to merge that idea. So I have 1/2 plus 1/4. Now, if I try to put them on the same number line again, or create the same amount of pieces, I'm going to multiply this by 4, right? 1/2 times 4, and I'm going to get 4/8. Now, on this side, I had 1/4, and now I'm going to multiply it in 2, basically. Multiply it by 2. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I end up now with 4/8. Now, if you look at this, I have 1/8 plus 1/8 plus 1/8 plus 1/8 equals 4/8, which is still equal to 1/2. Remember, these are equivalent fractions. 1/2 and 4/8 are equivalent fractions. It's not taking up any more space, but I have more pieces. And my pieces are getting smaller. So notice my half, the pieces are much bigger. And as I add pieces, I notice that my denominator is actually getting larger. All right, so now I have 4/8, and I'm going to add it to my 1/4 that now I have divided in 2. So it's like I essentially have moved this over here and combined it. So now I notice I have 1/8 plus 1/8 is 2/8. I have 2/8 still here. I divided it in half, and I have 2/8, right? 2/8. So 4/8 plus 2/8 is still 6/8. So 1/2 plus 1/4 is equal to 4/8 plus 2/8, which is equal to 6/8. So 1/2 plus 1/4 is equal to 4/8 plus 2/8, which is still 6/8. Okay? All right. Moving on to problem 2. Now, something I brought to your attention in the first lesson of Module 3 is the idea of unit fractions. Look. Let me get this right here. Okay. So unit fractions. A unit fraction is a fraction with 1/1 in the numerator. So now I have 2 unit fractions. So 1/3 plus 1/2. And 1 over anything is considered a unit fraction. All right, hold on one second. All right, so now I have 1/3, my unit fraction of 1/3 plus my other unit fraction of 1/2. So I have 1/3, I cut it up and I am illustrating 1/3. Now my second fraction, I'm illustrating it going horizontally. So I'm going vertically here and horizontally here. So 1/2, 1/3 plus 1/2. And I'm demonstrating it this way. So now what I have to do in order to create equal units, right? The adults and the children. So they both have to either all be children or all be adults or all be people. The units have to be the same. They have to be on the same number line. So we are going to take this and now we're going to double it. So we're going to double this by adding a line across here. Remember, I'm not taking up any more space. Notice that this is an equivalent fraction. I just multiplied it by 2, which I've told you before. What's the easiest way to create an equivalent fraction? Just multiply by 2. So 2/6, now that I divided it by 2, I divided it in, and I doubled it. So now I have 1/2 of 1, 2, 3, 4, 5, 6. Then over here, I have to triple it. So now I'm going to draw lines here. I'm essentially multiplying this by 3. So 1, 2, 3. I'm creating 3 equal spaces. Notice equivalent fraction. It's not taking up any more space. And now I end up with 1, 2, 3, 4, 5, 6. 6 equals pieces. And I have 3. Now I have 2/6 and 3/6. I have not changed the fraction. The fraction still is 1/3 plus 1/2. I'm just changing it and putting it on, creating like units so that I can add them together. And you cannot add or subtract fractions unless you have like units. All right, so now that I have both boxes broken up into 6 equal parts, now I can add up the pieces that I have. I have 1, 2, 3, 4, 5 pieces shaded in. Notice that's the same amount that we started with. So 2 plus 3 is 5, which is equal to 5, 6. So do our units get bigger or smaller when we create like units? So technically they're getting smaller. So you're right. Our units are actually getting smaller, but our denominator actually gets bigger. We're breaking it up into more pieces. So because we're breaking it up into more pieces, we have more pieces to account for. So it is our denominator does get greater. So we make more units by cutting them into smaller units. So you make more units by cutting them into smaller units. That's like having to share with your brother or your sister. And now you're getting a smaller piece, but you're making more pieces to share. So it's very much like the CGI problems that we do. The units get smaller because it is the same amount of space, but more parts. So the units get smaller, right? 1 unit becomes 2 units. 1 unit becomes 6 units. All right, so let's take a look here. 2/6 and 3/6. So 2/6 and 3/6. Well, if I have 1/3, oh, look at that. 1/3 plus 1/2 is really 2/6 plus 3/6. So essentially, I multiplied this. So I know a factor that they share is 6. So I multiplied by 2, and whatever I do to the bottom, I do to the top, and I end up with 2 6 plus 3 6, which equals 5 6. Hopefully you're starting to see what we're doing here. Now, knowing your basic math facts is absolutely key to having this become very easy for you. If you know your 2s, your 3s, your 4s, your 5s, if you know those really well, I guess all of them basically, but it makes fractions that much easier. All right, problem 3. So now we're starting with 2/3. And we're going to add the unit fraction of 1/4. So 2/3 plus 1/4. So if we model it, here is 2/3, right? And we have it shaded in, plus 1/4. And here, notice I have it going a different direction just so you can see how we're going to change it. Now, if I multiply this one by 4, so I know these are not like units. I cannot add these two fractions the way they are. I have to change them so that they're sitting either on the same number line, right? This is the thirds. This is the fourths. They are not on the same number line. I have to take these two and create a like units. So let's create like units. So if I take my third, here's my third, and I cut it into 4. So I multiplied it by 4. So I multiplied it by 4. So I cut once, twice, 3 times. Remember, if I'm trying to cut something into 4, I draw 3 lines. If I'm trying to cut something into 5, I draw 4 lines. So it's always one less line that you're actually than the unit you're trying to make. All right, then, so now I still have 2/3. Look, I'm not taking up more space, but I do have 1, 2, 3, 4, 5, 6, 7, 8. Now, 9, 10, 11, 12. I have 12 units altogether. And look, it's taking up the same amount of space, but now my units are 12ths. And when I multiplied that by 4, it's like multiplying it by 4. Now I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 12ths. Now over here, 1/4. So I started with 1/4, and now I need to create like units. So how am I going to take 4 and try to create a like unit? Well, now I'm going to multiply this by 3, right? So now I'm going to I'm going to put it up here because I went this way originally. Now let me cut downward this way. So now I have the same amount of spaces that I started with up here, but now I increased my units. I increased how many there are. So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12, and I have 3 of the 12. So now I can add these because now the denominators are the same. They are like units. They have the same amount of pieces. Now I can put them together. So I have 11 12ths. So 2/3 plus 1/4 is the same as 2/3 is the same as 8 12ths, and you can see it from here. 2/3 is the same as 8 12ths, and 1/4 is the same as 3 12ths. 1/4 is the same as 3 12ths. Add them together, 11 12ths. So 2/3 plus 1/4 is equal to 8 12ths plus 3 12ths is 11 12ths. All right. What can we say? What can we say about it? What do you think? So you know that when you are adding two different fractions, you need to create like units. That is the big idea, like units. So it's kind of like working with a puzzle, right? You have to cut out some of the pieces. You have to like start creating a puzzle where they all fit together. And this is I started vertically here, so I multiplied in that direction. I started in this direction, so I'm going to multiply in that direction. Okay. Not that that matters, but it's sometimes good to organize. So normally we would do a partner problem, and I would give you I'm going to give you 2/3 plus 1/4. And let me see how you do with that together. Show me if you can do that, even though we just did it. Now try it on your own. See if you can replicate what we just did. All right, moving on. So we have a couple of more partner problems. Here is 2/5. So I started with 2. I divided into 5 equal pieces, and I have 2 spots. I have 2 of the pieces shaded. Then I come over here and add, I have my other box, and I have 2/3. I have it cut into thirds, and 2 of them are shaded. Now, what did I do? I know I have to create like units. So what factor do they have in common? How can I multiply this in order to have like units? Well, I know that 5 times 3 is 15, and 3 times 5 is 15. All right, so now I'm going to take this original, and now I'm going to cut it. I'm going to multiply it by 3. So now I'm going to multiply this side by 3 and cut it in 3. And now I have 1, 2, 3, 4, 5, 6. I have 6 out of 15 total. Now over here, I'm going to multiply over going this way. I just multiplied going this way and divided it up. Now I'm going to multiply this by 5. 1, 2, 3, 4. So 1, 2, 3, 4, 5. I'm going to multiply this side by 5. And now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 out of 15. So when I add that up, I have 16 out of 15. Well, we know about whole numbers. We know that 15 over 15 is sitting inside this number, and I have 1/15 left over. So I know that I have 1 and 1/15. All right, so now let's have you try 2/7 plus 2/3. Here's your 2/7. Here is your 2/3. What common factor do they share, or product do they share? I wonder if you think 7 times 1, 7 times 2, 7 times 3, 7 times 4. And remember, I have showed you before how to scoreboard. So if you put 7 over here and 3 over here, here are our 2 denominators, and you went times 1, times 2, times 3, times 4, times 5, times 6, times 7, and then you went 1 times 7, 1 times 3, 2 times 7, 2 times 3, 3 times 7, 3 times 3, 4 times 7, 4 times 3, 5 times 7, 5 times 3, 6 times 7, 42, 6 times 3, 7 times 7, 7 times 3 is 21. So I stopped at 7, but you could go farther if you needed to. But the big idea with scoreboarding would be to find a common product that they share. So 7 times 3 is 21. 3 times 7 is 21, right? This is a strategy. But also here, knowing how to divide up these boxes to show how they are similar, how you could put them and create similar units, like units. Try it and come back and check. All right, so now, were you able to multiply this side by 3 and create 21. And now instead of having 2 7s, you have 1, 2, 3, 4, 5, 6. 6 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 6 out of 21 plus, here's our equivalent fraction. We multiplied by 7 going this way, so we added 7 lines going this way. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 out of 21. So now, how many boxes do we have colored in all together? Now they both have 21 boxes. Now I have 20 over 21. So 2 7ths plus 2 3rds is the same as 6 over 21 plus 14 over 21. Remember, these are equivalent fractions, is equal to 20 21st. So 2 7ths plus 2 3rds is equal to 6 21st plus 14 21st is equal to 20 21st. Okay? All right, so now we're going to go back. Now that we've kind of developed the concept, let's look at the problem set together. So let's take out the problem set and let's look at what they're asking us to do. So for the following problems, draw a picture using the rectangular fraction model. That means the boxes, the rectangular fraction model, and write the answer. Simplify your answer. Simplify your answer is take it down to its smallest possible fraction. So here you can go ahead and draw out the fraction, the rectangular fraction model, and do exactly what we were doing in the concept development, working on looking and noticing that those do become equivalent fractions. So that's what you'll do with these 6 here on the back. So we're working with fractions. So what do you think our word problems are going to be? That's right, fractions. So solve the following problems. Draw a picture and or write the number sentence that proves the answer. Simplify your answer. So Jamal used 1/3 yard of ribbon to tie a package. So here is 1/3 of a yard, right, of ribbon. So you remember how many feet are in a yard, how many yards are in it. Those are those little things that you want to go back to. Remember, there are 3 feet in 1 yard. All right, to tie a package, and 1/6 of a yard of ribbon to tie a bow. How many yards of ribbon did Jamal use? Oh, I'm so glad we don't have to convert our measurements. So 1/3 plus 1/6, how much did he use all together? So 1/3 plus 1/6 is going to tell us how much yards of ribbon he used altogether. So your answer needs to be Jamal used so much yards of ribbon. Remember, that is actually the answer. Just a number is not. All right. Over the weekend, Nolan drank 1/6 quart of orange juice, and Andrea drank 3/4 quart of orange juice. So again, 1/6, 3/4. How much quarts did they drink all together? Then Nadia spent 1/4 of her money on a shirt and 2/5 of her money on new shoes. What fraction of Nadia's money has been spent? Ooh, so how much did she spend? And how much money is left? So this one is going to be definitely a little bit more advanced, but it's a really great thinking problem. All right, I want you to try that and come back after you've completed not only the sprints, complete the problem set, and come back for the problem set debrief. All right, I think you guys got it.